Alright, so on this video I am going through the similar figures test review. Numbers 1 and 2, these are the mid-segment theorem. So remember, the mid-segment theorem states that if I have a line that is parallel to the other side and it is the mid-segment of the other two sides, I can tell that because I have congruent sides here and congruent sides here, that the mid-segment is half the length of the parallel side. So if I have the full length of the bigger side, I'm going to take 18 and divide by 2 to figure out the length of KJ. 18 divided by 2 gives me 9. On number 2, I want to go from small to big, so I want to multiply by 2, and this one gives me 18. Number 3 and 4 are again using the mid-segment theorem, but this time I have x's. So I know that my big length is x plus 9, and my smaller length is 2x plus 3. I know it takes 2 of the middle pieces to make one of the bigger ones, so I'm going to have 2 times 2x plus 3. Then I want to go ahead and distribute that 2 on the right-hand side. So I have 4x, and then 2 times 3 is 6. Then I want to go ahead and get all of my variables on the same side. So I'm going to subtract x on both sides. That's going to give me 9 on the left, 3x on the right, plus 6. Then I want to move that 6 over, so I subtract both sides by 6. I get 3 equals 3x. Then I want to divide both sides by 3, and I get x equals 1. So number 4 is going to work similarly. X plus 24 is my bigger side. And then I have 2 of the middle pieces that will make up this full length of the longer one. So I have 2 times 30 plus 2x. Then I want to go ahead and distribute that 2. So I have x plus 24 still on the left. 2 times 30 is 60. 2 times 2x is 4x. Then I want to go ahead and subtract x on both sides. That gives me 24 equals 60 plus 3x. Then I want to go ahead and subtract 60 on both sides. 24 minus 60 gives me negative 36. If I need to use a calculator, I can. And then I have it equaling 3x. Then I want to go ahead and divide both sides by 3, which will give me negative 12. On numbers 5 and 6, it's asking for the scale factor, a congruent angle, the relationship, and then to solve for x. So when it gives me 2 pictures and it doesn't necessarily say which one is going, I always assume my first picture is the old and my second picture is my new. So I want to take, remember, scale factor is new over old. So I want to take any of my side lengths except for the one that's going to pair up with the x and set it up as a fraction. So I'm just going to do RQ over BA. So I'm going to have 6 over 12, which I can simplify. Both of these divide by 6, which gives me, I wanted to write this in blue, 1/2 for my scale factor. B is asking me what angle Q is congruent to, so where this angle matches up to. If I look at my other shape, it matches up to this T over here. So I want to fill in this blank with a T. C is saying QR is to AB, so the side QR matches up to AB. RS is going to match up with this side over here, BC. D wants me to solve for x, so what I'm going to do is I'm going to plug in my values into this relationship that I have right here. QR is 6, AB is 12, RS is 4, and BC is x. And I got all of these numbers by looking at the shape and finding the side lengths and plugging in for the side lengths here. So now that I have my proportion set up, I want to go ahead and cross multiply. I have 6 times x, and then I'm going to have 12 times 4. Then I want to go ahead and actually multiply 12 and 4. That is going to give me 48. I want to go ahead and divide by 6 on both sides, which gets me 8. Then I want to go ahead and do the same thing on number 6. So I have my thing here. This shape is more on the right, so this is my old, and this is my new. I want to go ahead and take one of the new sides over the old. I'm going to do the KH to HD. So I have 15 over 10, which gives me, nope, I want to divide both of them by 5. Which is going to give me 3/2 for my scale factor. Then B is asking me what angle M is congruent to. It is right here, and it matches up to this angle over here, which is L. C says HM goes to KL, and then something is going to HK. So that is going to be GH. Then I want to go ahead and solve for x, so I'm going to set up my proportion, plugging in my values. HM was 12, KL is x, GH is 10, and HK is 15. So I want to go ahead and set that up. Now I can go ahead and cross multiply. So I'm going to have 12 times 15, and then I'm going to do 10 times x. Then 12 times 15 gets me 180. And it's still equaling 10x. I want to go ahead and divide by 10 on both sides. That gets me x equals 18. Okay. Moving on. 7 and 8 are again doing the same thing. So this is my old, this is my new. I want to go ahead and find my scale factor. So I want to match up any side that doesn't have an x. So I'm going to do 12 and 18. Both of these are divisible by 6. So 12 divided by 6 gives me 2. 18 divided by 6 gives me 3. This one is saying angle Q is congruent to this one. They're already marked for me. So this one matches up with L. Then my relationship has QR matching up to LK. And then RP should go to JK. Then I need to solve for x again. So I want to plug into my proportion. QR is 12, LK is 18, RP is 20, and JK is x. So now that I have this proportion set up, I can cross multiply. I have 12 times x, and then I have 18 times 20. 12 times x is going to stay 12x. 18 times 20 gives me 360. I want to go ahead and divide both sides by 12, and I get x equals 30. So again, I want to do the scale factor for 8. This one's my old, this one's my new. I want to take any matching sides. I'm going to do PN and JK. So I have 12 over 6. I can just divide this. It gets me 2. Then it says angle M is congruent to, this one is matching up to angle R. My ratio is PQ, matches to KL. And then, I don't know what side, should match to ML. So that is RQ. For D, I can go ahead and plug in my values for my scale factor. So PQ is 26, KL is 13, RQ is 22, and ML is X. So I again want to cross multiply. I have 26 times X and 13 times 22. $26X stays the same. 13 times 22 gives me 286. Then I want to go ahead and divide both sides by 26, which gets me 11. Okay. Number 9 is using the proportionality theorem. So I actually have two triangles here. I have PTQ, and then I have SRT. Remember, for the full length of PT, I want to add this together. So I have 2x plus 4, and then I'm going to add that 5, which is going to give me 2x plus 9. Over here I have 3x plus 5 plus 7, which will give me, if I add the 5 and 7, 12. Over here, I just have 5 and 7. Then I want to go ahead and set up my proportion. I have PT goes to ST. And then I have QT goes to RT. I want to replace those side names with these side measures. So PT is 2x plus 9, ST is 5, QT is 3x plus 12, and RT is 7. Then I want to go ahead and cross multiply. So I'm going to have 7 times 2x plus 9, and then I'm going to get 5 times 3x plus 12. Then I want to go ahead and distribute. 7 times 2 gives me 14x. 7 times 9 gives me 63. Then on the right side I have 5 times 3, which gives me 15x. 5 times 12 gives me 60. Then I want to go ahead and get all of my variables on the same side, so I'm going to subtract 14x on both sides. I get 63 on the left, x plus 60 on the right, because 15 minus 14 gives me 1. Then I want to go ahead and subtract 60 on both sides, which gets me 3 equals x. Okay. I want to again do the same thing for number 10. So I am going to split this up into two triangles. I have my big giant triangle, PQT, and then I have my smaller triangle, RST. For PT, I want to add the two side lengths right here. So I have 2x minus 2 plus 12. 12 minus 2 is 10. So I'm going to have 2x plus 10 for PT. Then I have 3x minus 1 and 21. 21 minus 1 is 20. So I have 3x plus 20 here. For RT, that is 2x minus 2. ST is 3x minus 1. Then I want to go ahead and set up my ratio. So I am going to have 2x plus 10 over 2x minus 2 equals 3x plus 20 over 3x minus 1. I want to go ahead and cross multiply. So I get 2x plus 10 times 3x minus 1. And then I have 2x minus 2 times 3x plus 20. Then I want to go ahead and FOIL on each side. Um, 2x times 3x is going to give me 6x squared. 2x times negative 1 gives me negative 2x. 10 times 3x gives me 30x. 10 times negative 1 gives me negative 10. On the right, I have 2x times 3x gives me 6x squared. Then I have 2x times 20, which gives me 40x. Negative 2 times 3x gives me negative 6x. And negative 2 times 20 gives me negative 40. Okay. Then I'm going to go ahead and combine like terms. So I'm going to start by subtracting 6x squared on both sides, which I am going to borrow the space down here. So that's going to cancel out 6x squared on both sides. Then I have negative 2x plus 30x minus 10 equals 40x minus 6x minus 40. That is off the screen. And the minus 40 looks weird. Okay, so then I want to go ahead and combine like terms. Negative 2x plus 30x gives me 28x. 40x minus 6x gives me 34x minus 40. Then I want to go ahead and get all of my x's on the same side. So I'm going to subtract 28x on both sides. That gets me negative 10 equals 6x minus 40. I want to add 40 to both sides, which gets me 30 equals 6x. Then I can divide both sides by 6, which gets me 5 equals x. So if I take a look at number 11, this one is telling me the ratio of two rectangles is 4 to 121. It tells me the perimeter of the larger rectangle. No, I need to find the perimeter of the larger rectangle. And I know that the perimeter of the smaller rectangle is 62. If I'm dealing with perimeter, my scale factor is exactly what it tells me. So I have 4 over 121. I know my smaller rectangle is 62. So because 4 is smaller than 121, 62 is going on the top. X is what I'm solving for. Then I want to go ahead and cross multiply. So I have 4 times x will give me 4x. And then I have 121 times 62. Then I want to go ahead and actually multiply 121 and 62. Which gives me 7,502. I want to go ahead and divide both sides by 4, which gets me x equals 1,875.5, and my units here is inches. So on number 12, I want to read the problem. It says the length of two sides of two triangles are in the ratio of 6 to 7. If the area of the larger triangle is 45 centimeters, find the area of the smallest triangle to the nearest 10. So because I have the word area, I'm going to want to square my ratio. So I have a normal ratio of 6 over 7, and I want to square this, so I'm going to distribute there. It's going to give me 36, because 6 squared is 36. 7 squared is 49. Then I want to go ahead and set up my ratio. I know that the larger triangle is 45, so that is going to go on the bottom of my ratio, and x is my unknown on top. So then I want to go ahead and cross multiply. We're going to have 36 times 45. And then on the other side, let me grab my green pen, I'm going to have 49 in x. And I want to go ahead and actually multiply 36 and 45, which gets me 1620 equals 49x. I want to go ahead and divide both sides by 49. Which gets me 33.06. On the test, I'm going to want to round to one decimal place, so it's going to be 36.1 centimeters squared. Okay, number 13 is talking about volume. Key number for volume is 3. So I'm going to want to cube my ratio. So I have 5 cubed, which is 125, and 7 cubed, which is not 7. On Desmos, I could type this in by typing 7, shift 6 to get the exponent, and then 3, which gives me 343. So that's the ratio I want to use for volume. Then it tells me the larger one, or it wants me to find the volume of the larger one. I know the smaller one is 486. So smaller was on top. Then I want to go ahead and cross multiply. I am going to have 125 times x. And then I'm going to have 343 times 486. On the left side, this stays the same. On the right, I get 166698. Then I want to go ahead and divide both sides by 125. Which gets me 1,333.58. So that's going to round because this is larger than 5. It's going to round that number up. So it's going to be 133.6. What's my units? Meters cubed. Numbers 14 and 15 are solving right triangles. So I'm going to break this up into smaller triangles. I have this giant one that had 12 and 6, and then I have this smaller one on the inside. I can see if I'm just focusing on the smaller one right here. My hypotenuse, my longest side, is the 6, and my up and down side length is x, my shortest side. So again, I want to set up my proportions. This one is going to be my new, and this one is going to be my old. So I wrote that too close to the 12. Let's write this over here. So what I want to do is I'm going to set new over old. So I'm going to have x over 6, this side to this side, and then I'm going to have 6 over 12, the hypotenuses being compared. Then I want to go ahead and cross multiply. So I'm going to have 12 times x. And over here, 6 times 6. Then I want to actually multiply 6 times 6, which gets me 36. I want to divide both sides by 12, and I get x equals 3. Number 15 is the same thing. So I have this giant one that has 17, 15, and 8. And then I have the smaller inside one. I'm going to draw it the same orientation. So just to clarify, I'm focusing on this tiny one right here. I want to, my medium side is the x, the hypotenuse is the 8. Then I want to go ahead and set up my ratios. So I'm going to have the up and down sides compared. So I'm going to have x over 15. And then the hypotenuses, so 8 over 17. Then I want to go ahead and cross multiply. I have x times 17, which is 17x. And then I want to go ahead and multiply these two over here. I'm going to have 15 times 8. 15 times 8 is 120. And the left side stayed the same. I want to go ahead and divide both sides by 17. And that gets me 7.05. So because this is a 5, I want to round to 7.1. So number 16 says Chris wants to reduce a triangle-shaped pattern with sides 16, 18, and 20. It says if the longest side of the new triangle is 15, so the longest side over here was on the bottom, I want to match up over here. I'm going to have 15 right here. And then it wants to know how big the other sides are going to be, so I have x and y over here. I'm going to set up a ratio. I have 15 over 20, and then I want to go ahead and pick a pair of sides to go. I'm going to go for my smallest side, so I'm going to do x and 16. I want to cross multiply, so I'm going to have 15 times 16. And then over here, I'm going to have 20 times x. 15 times 16 gives me 240 equals 20x. Both sides I want to divide by 20. I get x equals 12. Then I want to do the same thing for the medium side. So I still have the 15 to 20 ratio for the longest side. And now I'm going to match up y to 18. I want to cross multiply. 15 times 18. And then I'm going to have 20 times y. 15 times 18 is 270. Then I want to go ahead and divide both sides by 20, which gets me 13.5, and this decimal is nice and ends. Moving on, number 17 says a Ferris wheel casts a 20-meter shadow. A man 1.8 meters tall casts a 2.4 meter shadow. How tall is the Ferris wheel? So here's my Ferris wheel. I know that the shadow from it is 20 meters. And I know that the height is what I don't know. And this makes a triangle. Then I'm going to have a man. He is 1.8 meters tall, and he is casting a 2.4 meter shadow. So now I have two similar triangles that I can go ahead and set up in a proportion. I'm going to set up the shadows first. So I have 2.4 over 20 equals 1.8 over x. I want to go ahead and cross multiply. So I get 2.4x equals 20 times 1.8. That stays 2.4x, and 20 times 1.8 is 36. Then I want to go ahead and divide both sides by 2.4, which gets me x equals 15. So the Ferris wheel is 15 meters tall. Alright, my last four problems are asking me to decide if the triangles are similar by AA, side angle, angle, side, 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 or not similar at all. If I take a look at number 18, I have two labeled angles, and then because this is a bow tie picture, these two angles are congruent by vertical angles. So this one is similar by AA. Number 19, I only have two sides. I don't have any angles. This one is not similar because I don't have enough information. Over here on number 20, I want to go ahead and match up sides. So I am going to match up this 20 to the 60. And I'm going to do the smaller one on top. If I simplify this fraction, both of those numbers are divisible by 20, which gets me 1/3. I'm going to go ahead and check out another side length. So I have 13 and 39. Both of these are divisible by 13. That also gets me 1/3. My final set, I have 24 and 72. If I divide both of these by 24, I also get 1/3. Oops, I wanted to stay in green. So all of these have the same scale factor. That means this one is similar by side, side, side because I have three congruent sides on this triangle. On this one, I know that both triangles are going to have angle N. So if I drew this out as two separate ones, I have NCQ with side lengths 60 and 39. And then I also have this one, NRS, with side lengths 20 and 13. I know they share an angle, and I just need to confirm that the two sides are similar. So I'm going to look at the first set, the top ones. So I'm just going to do top over the bottom triangle. 60 over 20 gives me 3. Over here, oops, that was 39, not 30. I want to do 39 to 13, which gives me 3. So I have a pair of similar sides, a similar angle, and a similar side. This one is side angle side similarity.